Welcome to the world above our heads, where drones, helicopters, and airplanes rule the skies. Today, we'll unravel the real science behind how these flying machines work, what sets them apart, and why drones are changing the game. Whether you're a tech enthusiast, a filmmaker, or just curious about the future, this journey will reveal the hidden engineering and intelligence that keeps these machines aloft. Let's start by understanding the basics of flight, and why the sky is no longer the exclusive domain of pilots and large aircraft. Drones, also known as unmanned aerial vehicles or UAVs, are flying robots that can be remotely controlled or fly autonomously using onboard computers. Unlike traditional aircraft, drones come in many shapes and sizes, from palm-sized quadcopters to massive military machines. Their defining feature is the ability to fly without a human pilot on board, relying instead on advanced electronics, sensors, and software. But how do they actually stay in the air and move with such precision? Let's dive into the core components that make drones possible. At the heart of every drone are its propellers. These spinning blades generate lift by pushing air downwards, allowing the drone to rise and hover. Unlike airplane wings, which require forward motion to generate lift, drone propellers can create lift even when stationary, enabling vertical takeoff and hovering. The number and arrangement of propellers, like the 4 on a quadcopter, determine stability and maneuverability. Each propeller's speed is precisely controlled to tilt, turn, or hold position in midair. Driving those propellers are brushless motors, compact, efficient, and incredibly powerful. Unlike older brushed motors, brushless designs use electronic controllers to switch currents, reducing friction and wear. This means more power, longer life, and smoother operation. These motors can spin up or slow down in milliseconds, allowing drones to react instantly to control inputs or wind gusts. The result? Stable, agile flight that feels almost magical. Electronic speed controllers, or ESCs, are the nerve system between the flight computer and the motors. They receive commands from the flight controller and adjust motor speeds hundreds of times per second. This rapid response is crucial for maintaining balance and executing maneuvers. ESCs also protect the motors from overload and ensure smooth acceleration, making them essential for both performance and safety. Gyroscopes are tiny sensors that detect changes in orientation and rotation. In drones, they constantly measure how the craft tilts, turns, or spins. This data feeds into the flight controller, which makes instant corrections to keep the drone level and stable. Without gyroscopes, drones would quickly lose balance and crash. These sensors are the unsung heroes of smooth, controlled flight. Accelerometers work alongside gyroscopes to measure acceleration and movement in all directions. They sense when the drone speeds up, slows down, or changes direction. This information helps the flight controller understand the drone's motion and make precise adjustments. Together, gyroscopes and accelerometers form the core of the drone's stabilization system, allowing for smooth, responsive flight. The flight controller is the central computer that processes all sensor data and pilot commands. It calculates how much power to send to each motor, making hundreds of corrections every second. Modern flight controllers use advanced algorithms to keep the drone stable, execute complex maneuvers, and even fly autonomously. This tiny circuit board is what turns a pile of parts into a smart, self-stabilizing flying machine. Global Positioning System, or GPS, allows drones to know exactly where they are on Earth. By receiving signals from satellites, drones can hold position, follow waypoints, return home automatically, and even fly pre-programmed routes. GPS is essential for autonomous navigation, mapping, and precision tasks like aerial photography. Without it, drones would struggle to fly accurately over long distances. LiDAR, or light detection and ranging, uses laser pulses to map the environment in 3D. Drones equipped with LiDAR can detect obstacles, measure distances, and create detailed maps of their surroundings. Combined with cameras and ultrasonic sensors, LiDAR enables drones to avoid collisions, fly indoors, and operate safely in complex environments. This technology is key for delivery drones, rescue missions, and autonomous navigation. Drones communicate with their pilots or ground stations using radio signals. These signals transmit control commands, video feeds, and telemetry data in real time. Reliable radio communication is crucial for safe operation, especially in crowded airspace or during long-range missions. Advanced drones use encrypted links and multiple frequencies to avoid interference and maintain a strong connection. Modern drones can fly themselves using a combination of GPS, sensors, and artificial intelligence. Autonomous navigation lets drones follow preset routes, avoid obstacles, and complete complex missions without human intervention. This capability is transforming industries from delivery to agriculture, enabling drones to work tirelessly and efficiently in the background. Behind every smooth drone flight are sophisticated stabilization algorithms. These mathematical formulas process sensor data and make micro-adjustments to the motors, keeping the drone level and steady. Even in gusty winds or sudden movements, the algorithms work tirelessly to maintain balance. This invisible pilot is what makes drones so easy to fly, even for beginners. Drones rely on high-capacity lithium polymer batteries to power their motors, sensors, and electronics. These batteries are lightweight yet pack enough energy for several minutes of flight. Battery management systems monitor voltage, temperature, and charge levels to prevent failures and extend lifespan. As battery technology improves, drones are flying farther and longer than ever before. One of the most impressive feats of drone engineering is their ability to make hundreds of tiny corrections every second. Sensors detect even the slightest tilt or gust of wind, and the flight controller instantly adjusts motor speeds to compensate. This constant balancing act is what allows drones to hover perfectly still or perform acrobatic maneuvers with precision. Drones and helicopters may look similar, but their flight mechanics are fundamentally different. Helicopters use a large spinning rotor for lift and a tail rotor for stability, requiring complex mechanical linkages and pilot skill. Drones, especially quadcopters, use multiple fixed-pitch propellers and electronic stabilization, making them simpler and more reliable. This difference allows drones to hover, maneuver, and stabilize with ease, while helicopters excel at lifting heavy loads and flying in challenging conditions. Airplanes rely on fixed wings and forward motion to generate lift. They are highly efficient for long-distance travel and can carry larger payloads, but they can't hover or take off vertically. Drones, especially multirotors, can take off and land anywhere, hover in place, and maneuver in tight spaces. Fixed-wing drones combine some airplane advantages with drone flexibility, making them ideal for mapping and surveillance over large areas. Helicopters use intricate mechanical systems, swash plates, linkages, and variable pitch blades to control flight. This complexity demands constant attention from skilled pilots. Drones, by contrast, use electronic control systems and software to manage flight, making them accessible to almost anyone. Airplanes fall somewhere in between, with control surfaces like ailerons and rudders, but still require pilot input and aerodynamic knowledge. When it comes to efficiency and range, airplanes are the clear winners. Their aerodynamic design allows them to travel long distances with minimal energy. Helicopters are less efficient due to their hovering ability and complex mechanics. Drones, especially multirotors, trade efficiency for maneuverability and hovering, making them perfect for short, precise missions, but less suited for long-range travel unless they use fixed wings. Drones are unmatched in maneuverability, able to zip, flip, and hover with ease. Helicopters also offer impressive agility, especially in skilled hands, but require more mechanical complexity. Airplanes are built for speed and stability, excelling at straight-line travel but limited in tight spaces. Each machine's design reflects its intended use, from racing drones to high-speed jets. One of the biggest advantages of drones, especially quadcopters, is their ability to hover in place. This is made possible by electronic stabilization and independent motor control. Helicopters can also hover, but it requires constant pilot input and mechanical adjustments. Airplanes, on the other hand, can't hover at all. They need forward motion to stay aloft. This hovering ability is what makes drones so valuable for photography, inspection, and rescue missions. Helicopters can lift heavy loads thanks to their powerful rotors and robust frames, making them ideal for construction, rescue, and transport. Airplanes can carry large payloads over long distances, especially in cargo or passenger roles. Drones, while limited in payload compared to their size, excel at carrying cameras, sensors, and small packages. Their simplicity and modularity make them easy to adapt for different missions. Quadcopters are the most common type of drone, featuring 4 propellers arranged in a square. This design offers a perfect balance of stability, agility, and simplicity. Quadcopters are easy to fly, can hover precisely, and are used in everything from aerial photography to racing. Their electronic control systems make them accessible to beginners and professionals alike. Fixed-wing drones combine the efficiency of airplanes with the autonomy of drones. They use wings to generate lift and can cover large areas quickly, making them ideal for mapping, surveying, and agricultural monitoring. While they can't hover or take off vertically, their long range and endurance make them invaluable for missions that require covering lots of ground. FPV, or first-person view, drones put you in the pilot's seat with real-time video feeds. These high-speed machines are built for racing and acrobatics, offering unmatched agility and excitement. Pilots wear goggles to see through the drone's camera, navigating tight courses at breakneck speeds. FPV drones push the limits of control and reflexes, making them a favorite for thrill seekers and competitors. Military drones are larger, more powerful, and packed with advanced sensors and communication systems. They're used for surveillance, reconnaissance, and even combat missions. These drones can fly for hours, operate at high altitudes, and carry specialized payloads. Their autonomy and reach have transformed modern warfare, making them essential tools for defense and intelligence. Delivery drones are designed to transport packages quickly and efficiently, bypassing traffic and reaching remote areas. Companies are testing drones for everything from food delivery to medical supplies, promising faster and more flexible logistics. These drones use autonomous navigation, obstacle avoidance, and secure payload systems to ensure safe and reliable delivery. Artificial intelligence is taking drones to the next level. AI-powered drones can recognize objects, track targets, and make decisions in real time. This intelligence enables fully autonomous missions, from inspecting infrastructure to monitoring crops. As AI advances, drones are becoming more adaptable, efficient, and capable of handling complex tasks without human oversight. Drones have revolutionized filmmaking, allowing creators to capture breathtaking aerial shots that were once impossible or prohibitively expensive. With stabilized cameras and precise controls, drones can fly through tight spaces, follow moving subjects, and create dynamic perspectives. From Hollywood blockbusters to indie documentaries, drones are now essential tools for visual storytelling. Military drones provide real-time surveillance and intelligence, monitoring vast areas from above. Equipped with high-resolution cameras, infrared sensors, and secure communication links, these drones can track movements, identify targets, and relay information instantly. Their ability to stay airborne for hours makes them invaluable for modern defense operations. Drones are transforming delivery systems, making it possible to send goods quickly and efficiently. From delivering pizzas in urban centers to transporting life-saving medicine to remote villages, drones are overcoming traditional barriers. Their speed, flexibility, and ability to reach hard-to-access locations are changing the logistics landscape. In agriculture, drones are used for crop monitoring, spraying, and mapping. They provide farmers with real-time data on plant health, soil conditions, and irrigation needs. By automating repetitive tasks and offering precise insights, drones help increase yields, reduce costs, and promote sustainable farming practices. Drones are invaluable in rescue missions, reaching disaster zones quickly and safely. They can search for survivors, deliver emergency supplies, and provide real-time video to rescue teams. Their ability to fly in dangerous or inaccessible areas makes them a vital tool for saving lives during natural disasters and emergencies. Drones equipped with cameras and sensors can create detailed maps and 3D models of landscapes, construction sites, and infrastructure. This data is used for planning, monitoring progress, and detecting issues early. Drones make mapping faster, safer, and more accurate than traditional methods, benefiting industries from construction to environmental science. Drone racing has emerged as a thrilling new sport, combining high-speed flight with immersive first-person views. Pilots navigate obstacle courses at incredible speeds, pushing the limits of reflexes and technology. Racing leagues and events are drawing crowds worldwide, showcasing the excitement and innovation of drone technology. AI automation is making drones more capable and independent. From automated inspections of power lines to monitoring wildlife, drones can now perform complex tasks with minimal human input. Machine learning algorithms help drones recognize patterns, adapt to new situations, and optimize their operations for maximum efficiency. The concept of flying taxis is moving from science fiction to reality. Companies are developing large, autonomous drones capable of carrying passengers across cities. These flying taxis promise to reduce traffic, cut travel times, and open up new possibilities for urban mobility. While challenges remain, the future of personal aerial transport is closer than ever. Swarm intelligence is a breakthrough in drone technology, allowing multiple drones to coordinate and work as a team. Inspired by nature, these swarms can cover large areas, share information, and adapt to changing conditions. Applications range from search and rescue to environmental monitoring and even entertainment. Drones are becoming an integral part of smart cities, helping with traffic monitoring, infrastructure inspection, and emergency response. Their ability to collect data and respond quickly makes them valuable assets for city planners and first responders. As urban areas grow, drones will play a key role in making cities safer, more efficient, and more connected. Drones are being used to create aerial internet networks, bringing connectivity to remote and underserved areas. By acting as flying relays, drones can provide internet access where traditional infrastructure is lacking. This technology has the potential to bridge the digital divide and connect millions of people worldwide. Personal flying devices, once a fantasy, are now being developed using drone technology. These compact, user-friendly machines could one day let individuals fly short distances safely and efficiently. Advances in batteries, AI, and safety systems are bringing personal flight closer to reality, opening up new possibilities for recreation and transportation. The future of drones lies in fully automated aerial ecosystems, where fleets of drones operate seamlessly together. These systems will handle everything from deliveries and inspections to emergency response and environmental monitoring. By integrating AI, communication networks, and advanced sensors, automated aerial ecosystems promise to make our skis safer, smarter, and more productive. As drones become more capable and widespread, balancing innovation with safety is crucial. Regulations, air traffic management, and privacy concerns must be addressed to ensure responsible use. Industry leaders, governments, and communities are working together to create standards that protect people while enabling the benefits of drone technology. Behind every drone are skilled pilots, engineers, and innovators pushing the boundaries of what's possible. Their expertise in robotics, software, and aviation is driving the evolution of aerial technology. As drones become more autonomous, the human element remains vital for creativity, safety, and ethical decision-making. We're entering a new era where drones, helicopters, and airplanes each play unique roles in our skis. Drones are leading the way in autonomy, flexibility, and accessibility, while helicopters and airplanes continue to excel in power and efficiency. As technology advances, the boundaries between these machines will blur, opening up endless possibilities for exploration, connection, and innovation. The sky is no longer the limit, it's just the beginning.